there are a number of different ways that the cell membrane is involved in the regulation of the cell and what passes into and exits the cell. And when we're looking at things that are large in size, so larger particles and liquids, then they're going to have some difficulty passing through the membrane, through the fluid mosaic model of the membrane, passing straight through the phospholipid bilayer or a particular protein. And in this case, we're going to need to see different processes occur in order for large particles and liquids to move into or out of the cell. So these processes are called endocytosis and exocytosis. So endocytosis is when things are trying to enter the cell, and exocytosis is when things are trying to exit the cell, so leave the cell. So endocytosis is entry into the cell, exocytosis is exiting from the cell. So what happens is in endo and exocytosis, we have these small little things called vesicles, and they're a little loop that basically is just a little loop of a phospholipid double membrane. So if I was to then draw sort of a little circle here and say this is a cross section of what this little vesicle would look like, we would see that it's made up of a phospholipid bilayer and would look something like this. So for the purpose of this tutorial, I'll just draw straight solid lines. I won't do the phospholipid bilayer because it would take a little bit of time. So in exocytosis, so I'm going to draw exocytosis first. In exocytosis, what actually happens is a vesicle, so a little ring or a little loop or a little ball of a phospholipid bilayer is going to form a capsule that's going to transport things either into or out of the cell. So in exocytosis, we're talking about out of the cell. So say a cell has just made a heap of proteins that it needs to send out into the environment somewhere external from the cell. So we'll have a little vesicle here that will have some proteins. As they're a larger particle, they can't just pass straight through the cell membrane. So we have a vesicle that's going to encapsulate these proteins and it will make its way to the cell membrane. So let's say we have our cell membrane here. Let's say that this is the inside of the cell and this is the outside of the cell. What's going to happen is this vesicle is going to make its way out to the membrane and it is going to start to fuse with the membrane, remembering that it can do so because it is made of the same phospholipids. So a vesicle is going to go and fuse with the membrane, there are proteins in it, and then what is able to happen is this fusion can cause or allow an opening in the vesicle. So the vesicle will fuse with the membrane and then start to be stretched or pulled apart by the cell membrane, allowing these proteins to then make their way out into the external environment like so. So that's the process of being able to remove a larger particle from the inside of the cell out into the external environment. Let's have a look at endocytosis. And endocytosis can be divided up into two different types. So the first of which I'm going to look at is something called phagocytosis. So phagocytosis generally has a meaning, phago meaning to eat. That means to eat or swallow or kind of consume. So in phagocytosis, the cell membrane is going to swallow or eat something large from the external environment using a vesicle and the cell membrane in order to then consume it or take it inside. So what we'll see is, say we have a particular large molecule on the outside of the cell. What's actually going to happen is the cell membrane is going to start to fold around it. So remember, this is the outside of the cell, this is the inside of our cell. We see the membrane is able to collapse a little bit and allow this large molecule to sort of start to move into the membrane, and it's going to gradually form a bit of a capsule around it. So you can also, you can kind of imagine that this is like a mouth. It creates The cell membrane is creating a mouth which is starting to swallow this large particle. What will then happen is this section of the membrane will close off and form a vesicle. We have our large particle inside like so. So this is our vesicle, and this is the inside of our cell. This is the outside of our cell. What you can see now is the cell membrane has closed up. So this original gap here has now closed up, and the vesicle is then free to be transported or moved into the cell with that large particle inside of it. Our second type of endocytosis is something called penocytosis. And this translates to drink. So this is to do with liquids. So what will happen in the case of penocytosis is much more or less similar to phagocytosis, but it involves liquid. So similarly, what will happen is we have our cell membrane, and say we've got a liquid that contains a bunch of different things. It might be some salts, some sugars, different types of solutes that our cell wants to get hold of. So same again, what we see is that the cell membrane will start to collapse inwards and allow this liquid containing solutes to start to sort of fold into the pocket made by the membrane, and it starts to suck them in or drink them in. And then what we'll then see is this section here will close off. We see a fully encased section of the phospholipid bilayer form. We end up with a vesicle which is going to contain the liquid that the cell has drank with some of the solutes inside that the cell requires. So that is how the cell membrane is involved in the processes of exo and endocytosis, allowing larger particles and liquids to enter or exit the cell.